All right, so what was due last night was this study guide, which is the last link under next last link under week 3, metric conversions assignment. And it provided an answer key to that assignment in the folder for this week. Here we are under week 4. Answer key for metric conversions assignment 1. So if you open this up, you can see down through here all the correct answers I've provided here. And remember, this is based on the notes that we took. And here's a screenshot of those notes. You can still go back and watch. They're posted on, this was from Friday's notes. We have base units and we have these different metric prefixes. Here were some example problems. So you can use those and go back and check that link. But I want you to open these answers and open your document and take a look at those for the next few minutes. Why don't we take 3 minutes, check over your answers, and then let's see what questions you have before we move on to more with scientific notation. Okay, I'll see you back in 3 minutes. All right, so we're back. Any questions on those? All right. And now, back to scientific notation. So yesterday I told you to take a look at these 2 links, and they're really quick and easy links, but I really like them, especially this link. Well, I shouldn't say that. I like both of them. When we have a huge number like this is the mass of the sun. Instead of trying to count all these zeros, we use scientific notation. So if there's a 2 with 37 zeros, then we write that as 2 times 10 to the 37th power, which we can also write as 2e37. And likewise, if we have a really small number, which is the mass of a proton, we can write that in scientific notation. It's much easier to keep track of. So I really like this explanation. I think this young lady does a great job at explaining how to convert between standard notation and scientific notation. Standard notation is sometimes called full decimal on some calculators. So scientific notation, she explains that the decimal point must go here such that only one non-zero digit appears to the left of the decimal. And then we have times 10 to some power. This can be replaced with capital E with a 4 next to it. Means the same thing. All right. She says, let's look at some example problems, right? So if I write this in scientific notation, the first thing I understand is that the decimal point must move to here, between the 7 and the 2, because I can only have one non-zero digit to the left of the decimal. So you decide that, and then you count over how many places the decimal must move. 1, 2, 3, 4 places. Now the next thing, so you know your exponent is a 4, and the next thing is it a plus or minus 4? Well, since this is a number smaller than 1, the exponent is going to be a minus 4. And so here she's going through this explanation, similar to what I just did. And then you can see there's the answer, 7.211 times 10 to the minus 4 power. We can replace this with e minus 4. They mean the same thing, right? So she goes through a couple of examples of these and then goes backwards too and says, well, if I have a number in scientific notation, write it in standard notation or standard form. And then a negative exponent denotes a really small number, typically a number, well, always, not typically, a number less than 1. So to make this a number less than 1, I'm going to move the decimal to the left 3 places. And then she takes you through that. And these were some good examples, and there we go. So this is a nice little clip, and you get to hear somebody besides me. I would be giving you the same exact explanation. I think she does a great job of this, um, and it's very animated. And look, she's got a nice background here, and I don't have much of a nice background here behind me right now. But anyway, good clip. Let me see. Do we have any questions so far? No. And so we looked yesterday at the scientific notation and metric conversions, and this page is due tonight, and I see a number of people have turned it in already. So that paper, no, that's not that one. Let me open someone's, no, I think I have it open right here. No, that's the answer key. This one was the one with the boxes, right? Yeah, I think it's this one, right? Powers of 10 conversions. Yes. So we talked about this yesterday, and you guys worked on this a little bit yesterday. This E4 means times 10 to the fourth power. So to expand that to full decimal or standard form, I'm going to move that decimal 4 places. Since this is a positive 4, I'm going to move it to the right 4 places, and I keep the same units. And now for the next column, I'm changing from millimeters into meters because it says base units. So I'm moving 3 places to the left, and then I have 12.30. So this assignment is due tonight. And down at the bottom, I didn't have any exponents with these, so I just moved them out here, and you can convert those to base units out here to your right. So how are we doing so far this evening? Let's look at another scientific notation assignment. This is a second scientific notation assignment that I want to share with you, and I'll share it in just a minute. But I want to take a look at this together first. So if I have, if I have a number in standard notation like this, sometimes you see the period at the end, and sometimes you don't. So 384,000. And I want to put that in scientific notation. First thing I decide is, where does the decimal go? It has to go between the 3 and the 8. So then I ask, how many places does it move? The answer is 1, 2, 3, 4, 5 places. Next question is this a number bigger than 1? It is. Therefore, the 5 is a positive 5. So I could write this in scientific notation like this, times 10 to the 5th. That caret, this is called a caret, is above the number 6 on your keyboard. Or I can write it like this, and sometimes it's easier to write it like this, and oftentimes I do. But either way is fine. Now the next number, notice I started with a number bigger than 1, and then number 2, smaller than 1, bigger than 1, smaller than 1, bigger than 1. To kind of, you have to get your brain to reset on each problem. Right? So here we can see that the decimal point is going to be between the 2 and the 3 and the 4. I'm sorry, between the 2 and the 3. 1 digit to the left of the decimal. So now I count how many places did that take to happen, and it's 6. Is this number bigger or smaller than 1? It's a number that's smaller than 1, so the 6 is negative. And here I can write my answer in scientific notation. So 1 through 10 is like that. And then at number 11, I start on the other end. And I give you a number in scientific notation, and I have you write it in full decimal, or also known as standard form. So here, I know if I have a positive exponent, then I'm going to make this number bigger than 1. So to do that, I'm moving it to the right 3 places, and there I put it right here. So I know for some of you, this is review and you've seen this before. Some of you need more practice on this. We're at different places on on these types of problems. So this is common. We see these numbers a lot. We work with a lot of numbers in scientific notation in this class because there are a huge number of atoms that are in a balloon of gas. There are a huge number of molecules of water in a glass of water. If I have a glass of water, there's 10 to the 23rd molecules in there for like a third of a glass of water. So we have to work in scientific notation. There are many cases that we will do that throughout the course. So you need to be able to move back and forth.